Greeting to those who watching this video. My name is Lim Jun Yi. I'm from University Malaysia Police. So in this video, I will like to share some of the project or tasks that I involved during my internship. So I'm doing my internship at SD Guthrie. And I was placed under the robotic teams. So what you can see here, the left side is the robotic center at Carey Island, and this is me. Okay, the first project that I would like to share is called palm tree detection. So this is a group project where I doing this project with other interns and protege. So we were assigned the task to develop a palm tree detection model. This video shows that um I'm taking do the data acquisition. Yeah, we use the DJI drone to take the palm tree data from top. Okay, the right side is the inference test. Okay, of course, in the between we have do some data labeling, augmentations, and then some and trainings. And the right part is the end result, the inference test. Okay, so we also once we finish the project, right? So we also have to present it to the robotic teams, and these are my teammates lah, who working on this project. Okay, so this is another project. So it's very similar to the previous project, which is detection, but this one is um, more difficult because this is the actual project that the team is currently doing, which is called FFB detection and counting. So I was given a task, this task to develop the model that able to do this. So as you can see, the left video is where I'm do the data acquisition. I record the dataset in video form, and then I um, convert it to the image via the Python script. After the data collection is finished, then I upload the data set to the RoboFlow website, do some data annotations, and then some image processing, image augmentations, and then I download the data sets, and then I train uh, in my local computer with GPU. At the same time, I also record all my trainings at the ML flow. So this allow me to keep tracking and do some comparison between the model, each model that I train. Okay, so this is the inference test of this project. So the middle line is the counting line. Whenever the center point of the bounding box cross it, so the count will plus one. Okay, so let's see. Okay, plus one. Okay. Okay, drone study. So during my internship at the robotic teams, I was placed under the drone team lah. So basically, I will work with the engineer with drone related project. And before this, right, I have zero knowledge about the drone, so I do take some times to uh, catch up, uh, or we call it as a study the basic of the drones from in terms of the hardware and software. So is what you can see right now here is the simulation world. Uh, the the tree, the tree and the terrain is developed by the previous engineer. So what I do is I take all these tree, and then I create my own custom gazebo world, and then I do some flight testing in this world. It allow me to test different flight mode before try to fly the real drone. Okay, so these are some of the few testing that I have involved during my internship. The first one is called RTK signal troubleshooting. So basically, we have the RTK signal loose. So what we discover that is because of the EMI, electromagnetic interference issue. So the way we cope this problem is we decide to increase this RTK antenna above, so that it has a distance between this RTK antenna and this, we call it ops block. Okay, the second video you can see is the battery duration flight test. So basically we charge full the battery, and then we want to know how long the battery can last. What's the maximum duration of the flight test when the battery is full. Okay, the third video you can see here is three circling flight test. So um, basically we just want to try to fly the drones circling around the tree. Okay, so beside those manual flight drone, so I also given the opportunity to explore the autonomous drone system, where I need to where I study from the perception to localization to planning until the control. So what you can see right now is I try to make the drone fly autonomously uh, with the given waypoint in the mission planner. So the drone can fly autonomously above the canopy. We just simply give the waypoint in mission planner. But for the drone, if you want to let the drone fly below the under the canopy, we cannot just simply use that method. Because under canopy has a lot of obstacle. That's why we need slant, we need path planning. So one of the slant that I studied during my internship is called RTMap. So RTMap is a library that allow to generate a 2D or 3D map given using the lidar or the depth camera. So what you see right now is one of the simulation that I explore. So I also try to apply this RTMap in my own digital mobile robot. Okay, so this is the outputs lah, how it looks like. Okay, so beside the slam, I also have I also have spent some times research. I mean, try to learn do some study on the fast planner algorithm. So fast planner algorithm able to generate collision free path that allow the drone to follow and to avoid the obstacle. So it basically something like obstacle. It allow the drone to have a obstacle avoidance feature lah. So I do spend more time on here because and here this is RQT graph. So I have I have studied in details on what are the exact input needed by these algorithms and what is the exact output that generated from this algorithm, so that it able to um, use by the real drone. So basically you have three inputs lah. And then okay, so so these are the pipeline that I propose to the engineer at here. So where we are, so right now we are at this stage. Basically what we doing right now is we want to make the drone to communicate with the rose which is in the Jetson. So once we have this, so we will straight away move to this part. I think after we discussion with the engineer here, we try to skip this part and try to apply path planner to do the obstacle avoidance. These are some of the inputs that require, which I already verified through the source code. Okay, so these are the current progress. So during my internship, I have tested the artemet on the Z camera.
Okay.
I tried the launch file and see whether it's working or not. Okay, so the middle one, the video clip, is where I install all the necessary packages like Mefros, Mefproxy in the ZSON, and then I make the flight controller unit from the drone to talk with the ROS. So these are some of the topics they're publishing. So the third video is we arm the drones, and then we want to check whether the odom is publishing or not. And
Okay.
yes, the odom is publishing during this test. Okay, I think that's all for my sharing. Thank you.